Well, hello Internet, and welcome to my Kotlin video tutorial. In this one tutorial, I'm going to cover pretty much what you would find in a standard 250, 300-page book on Kotlin, which means the core syntax of the entire language. And like always, in the description underneath the video is a link to all of the code from this video, as well as timestamps to all the individual parts of the video, so you can watch whatever you want, or watch part of the video and come back to it, or do whatever. And also, I'm going to show you how to install everything you're going to need to complete this video. And I have a lot to do, so let's get into it. Alright, I'm guessing you already have the Java Development Kit installed. If you do not, then you're going to have to go, just type in Java Development Kit, don't worry about this, and you're going to come to a page that looks like this, and you're going to find whatever operating system you are using, Linux, Mac OS, Windows, whatever. Click on that and install that stuff. And I'm going to go pretty quickly here. Then you're going to need to go to jetbrains.com IDEA and download. And more specifically, whether you're on Windows or Mac OS, we're going to be using the free community version. So you're going to click on download. And if you're on Mac OS, you're going to see this little guy pop up down here, DMG. Click on open, and then you're going to the folder that opens. You're going to grab the IntelliJ application and drop it in your applications folder. And then whenever you do that, this guy's going to open up. You're going to decide if you want a white interface or a dark interface. Click on Key Maps and click on I've never used IDEA and click on Launcher Script. Check mark inside of here and click on Default Plugins, and all this is fine. Just click on Featured Plugins. All that's fine. Click on Start using IntelliJ. Then to create your very first Kotlin project, whenever this guy opens up, click on Create New Project. Come over here on the left side of the screen, click on Kotlin and click on Kotlin JVM and click on Next. This guy's going to pop up here. Give your project a name. I called mine Kotlin Tut. This is automatically going to open up like this. You're going to click on Project SDK and you're going to click on this guy and go and find whatever JVM you want to use. Come down here, click on Finish. Whenever you do, this is going to open up. You're going to come over to your source directory, right click on it, click on New, and then Kotlin File Class. This guy's going to pop up inside of here. Give it a name. I called mine Kotlin Tut again. Call it whatever you want. Click on OK. And then you're going to type the simple hello world script inside here just to verify everything works. Type exactly what you see there. And you can click on pause if you want to check that out. And whenever you do, hello world's going to print down here. You're probably more than likely going to see this. It's a bug. Don't worry about it. Your applications are going to compile perfectly fine. It's just a known bug that will go away finally or eventually. And that's how you install both IntelliJ and Kotlin on a Mac OS computer. And now I'll show you how to set it up on Windows. Basically the same thing. Alright, so you're going to go to jetbrains.com, IDEA, download. You're going to come over here, click on Windows, and then you're going to click on download. Then this guy's going to pop up down here. You're going to click on save. This is going to pop up and you're going to click on next. And this is perfectly fine. Click on next and leave everything the way it is. Click on next and it is going to install everything for you. After it's all done installing, you're going to see this guy. Leave this Run IntelliJ Community Edition checked and click on Finish. And what we're going to do here is do not import settings and click on OK. And then you're going to check if you want a white or a black interface. Click on Default Plugins. Leave everything the same. Featured Plugins. Start using IntelliJ. Click on that guy. Come in here. Create a new project. You're going to come in. Click on Kotlin. Kotlin JVM. Come down here. Click on Next. Come back up inside of here. You're going to click on Give Your Project a Name. You're going to click inside of here to select the SDK you want to use. And you can see right there, I use version 1.8, and then I'm going to click on Finish. This is going to open up. You're going to come over to Source, right-click on it, click on New, and Kotlin File Class. You're going to type in exactly what I typed in before. I'll show you that here in a second. Oh, by the way, if you want to run your code, you're going to click on Run, and that's going to run it for you. And whenever you click on Run in Windows, it's going to come up like this. So you're going to click on Demo, Kotlin, Tut, or whatever you called yours. Click on that. By the way, here is the simple Hello World application I'm going to use to verify that everything is installed properly. And after you run it, you're going to see down here that Hello World prints out. All right, so now you have Kotlin and IntelliJ and all that stuff installed. Now let's start writing some code. Alright, so this should all look familiar because that's exactly what you have here. Oh, by the way, everybody always asks me, how did I get this from the bottom to the right? You're going to right click on it like that, and you're going to click on Move To. And you're going to go top, left, bottom, or right. Okay, so that's how I did that. Alright, so let's write some code. First thing I want to talk about are variables. Oh, by the way, this is where all your application, this is your main function. This is where everything is going to execute. And then right here, you can see is how you print out to screen. Very first thing I'm going to talk about are variables. Now, there are different types of variables. There are mutable and immutable. And immutable, sometimes referred to as read-only variables. And you create an immutable or an unchangeable variable by typing in val. And then let's say name is equal to Derek. Okay, there you go. You just created yourself a read-only variable. You could also create mutable variables inside of Kotlin by changing val into variable. And I'll say something like my age is equal to 42. Okay, my name hopefully is never going to change, and my age more than likely will. So that is the difference between those two guys. Now, Kotlin uses what is called a type inference. So whenever I put a string inside of here, Kotlin knows that this is a string and it refers to it as a string. Likewise, here it's going to refer to my age as an integer. And those squiggly lines are there because you can see right here, variable my age is never used. All right, IntelliJ is very verbose with warnings. So what I want to do here is, even though it will figure out what the type is on its own, you can also come in and define your type. So let's say I want to come in here and I want to create a mutable or changeable variable, and I'm going to call this big int, and I want this to be an integer. Well, you may ask yourself, well, how big of an integer can I store inside of there? Well, I can go and call max value, and it will tell me exactly that. And we're going to find out what that is. And then we can go and call this small int, like that, and I will just change this to min value, and then I'll be able to get that value as well. I can then come in and go print line, and I'll say something like biggest int, and we can go and put the information in here in multiple different ways. One thing we can do is just put a plus sign inside of there and then put big int like that. Or we could also come in and we could say smallest int, and this is obviously going to be big int, but I'm going to get rid of that altogether, and I'm going to put that guy right there. And you can use what is called string interpolation, which is going to allow me to put small int inside of there. And how I do that is I come in and I put a $sign followed by whatever the name is for my variable. And you can see it gives me all sorts of different information here. All right, so we got that all set up. And if I want to run it, I can come in and run it, and it's going to print all of that out. And there you can see the biggest integer I can have is that big number, and the smallest integer is that number. And there's two different ways to place that information or print that information out on my screen. Don't worry about all of the warnings. They're just telling me I'm not using this and that. All right, let's get rid of that so that warnings go away. Now, there are, of course, many other different variable types. You're going to have integers, which are referred to using int. You are also going to have longs, and here in a second, I will show you how big or how small a long can be. You're going to have doubles. You're also going to have floats. You're also going to have booleans, boolean. And as per numbers, you can have shorts, which are going to be 16 bytes. Or you can have bytes, which are going to be 8 bytes. And let's go in here and, also you'll have characters. I'm going to show you examples of all these different guys though. All right. All right. So I went in here. I already showed you. I typed in how to find out the biggest int and the smallest int. I then went in and created the largest long and the smallest long, the largest double, and so forth and so on, and floats and all that fun stuff. We're going to run it, and you're going to see over here on the right side of the screen all of that. Look how big longs are. These are huge. All right, and there is the biggest double and the smallest and all of those different things. Now, one thing that is important to be aware of, however, is there is a loss of precision whenever you are working with floating point numbers. And let me go and give you an example of what I mean by that. Let's go and create a variable and double num1, and this is going to be a double, is equal to, and I'm going to go 1. And what you're going to do here is you're going to, with your doubles, you're going to have a precision up to 15 digits. So even though they can be gigantic, they're really not. So what you want to be aware of is I'm going to go, okay, so there is 15 digits. Let's add 16 on there. And then we're going to come in here and we're going to copy that, paste that inside of there, change this to double num2. And then I'm going to print out the difference, or the sum. Let's do a sum. And then you'll be able to see how it fails whenever I'm working with it. So you can also come in here and go plus sign like this, and you could go and perform your arithmetic directly inside of here, double num1 and double num2 like that. No, you probably have noticed there are no semicolons inside of Kotlin. Let's run that. And you're going to see that everything added up perfectly fine, a whole bunch of ones, until it got right here to the 16th digit, and then it messed up. So just wanted to make you aware that precision falls apart after 15 digits. Of course, you should always verify that on your own computer, though. Now let's take a look at booleans. Booleans can either have a value of true or false. That is it. So let's go into a real simple example. So I'm going to say if true, and what you can do here is you can use the phrase or keyword is to see if a variable is an integer or a double or a float or a boolean, and that's what I'm doing right here. So I'm saying, is true a boolean? Yes, I can do that. And then I can come in. You can also come in here and put print like this and go true is boolean. And then what this is going to do is print out the screen but not add a new line. But you can go in here and put a new line in there for yourself and do that, and it's going to come back as true. True is boolean. All right, good stuff. And let's do one more example here with variables before I get into casting and a couple other, well, a lot of other things. Let's go and create a character. How we do that is, let's say something like letter grade, and I'm going to go character like this is equal to, a character is going to be surrounded with single digits, and there you go. There is a character. And I could come in here just to verify that this indeed is a character by saying A is a and character. Whoops, spell character right. There we are. And we can come in and go plus. And, well, actually, you can do something else. I can go and perform this without using that plus sign. I can go a $sign and put 2 curly brackets in there. And then I can go letter grade is a character. And that is all legit, and we can run it, and you can see that indeed it's going to come back A as a character and true is indeed true. So that is how another way we can use string interpolation, and now I want to show you briefly how casting works. Now if you want to cast from one value to another, let's go and just get rid of that altogether right there. You can, it's quite easy. So, well, let's paste this in here and let's just change what this is. So let's say we wanted to go 3.14 to an integer. So we can cast from a double to an integer. Well, I could then come in and go 3.14. And if you want to cast a double or a float to an integer, you just put a dot and 2 int followed by the parentheses, and it is automatically going to do that for you. Whoops, forgot to put the plus sign. All right, so there's that. That's how we can convert from a double to an integer. And let's go and convert from a letter grade, just to show something weird. It works with any of them, so just go in there and play around on your own, and you'll see. So let's convert an A into an integer, see how that works out. So I'm going to go letter grade. Well, I've deleted letter grade. So let's just get rid of it, and we'll just go, I can put it directly inside of here, surrounded with single quotes, and then go to int. Kotlin doesn't care. All that's cool. And then we can come in and what do we want to do with the next one? Well, we can get that value right there. We'll say 65 to character and see what that works out to be. So we'll put 65 inside of there, and we'll say to character like that. And we can run all those guys, and you're going to see that all of those work. And that's how casting works inside of Kotlin. And now I'm going to jump over and show you a whole bunch of different things we can do with strings. All right, so strings are just double quoted series of characters, and of course we put val inside of there. What does that mean? That means that's a value that is not going to change. And we can go and put my name inside of there, if I can remember how to spell it. There we are. So there we are. We just created a string. And let's go and create a long string. So we'll go long string. You can also come in here and put double quotes again, but we're going to put 3 of them. And this is going to allow me to, let's put something different inside there. This is a, come down here, and I can go long string. and then it won't edit that at all. It allows me to do multi-line strings or whatever you'd like. Let's go and create a couple more here. Let's go first name is equal to, and I could also come in here like this and go string and define it if I didn't want it to go in there and infer what I'm doing. Either way it works out. So I'll go Doug, and let's just copy this guy right there and come down here, and let's go L name, and this will be Doug Smith. Of course, we're going to be able to come in here and join these together. Actually, you can also change the value. Remember, val you don't change, var you can. So let's change it. So I can just come in and go f name is equal to Sally. All right, so we were able to change that value. And let's say we wanted to go in and join these strings together. Of course, we could do that. We can just go f name plus, and there's like that, and L name. And there we go. That's how we go and join our values together. Whoops, change that to an uppercase. There we are. All right, so that's how we can join strings. Like I said before, we're going to be able to use string interpolation, or just putting a variable value directly inside of a string that we plan on printing out. So we can go name like that, and we can go full name like that, and that's going to print that guy out. Let's go and do a whole bunch more of these guys. You're going to, like I said before, you're going to be able to print out. I never know when you guys are using timestamps to jump around and doing whatever, so I'm going to cover this again. You're also going to be able to come in here like this with $sign and curly brackets and perform arithmetic operations directly inside of your string you want to print out, and that all works good. You're going to be able to get your string length. Let's go and just copy this guy right here, paste that inside of there, and I will have all this stuff. Whoops, keep this like this. So I'm going to go string length, and then if I want to get to that said string length, let's go it for the long string. I could do so like this, and then follow it up with the word length. What else can we do? I can compare strings, so I could create two brand new strings here if I would like, or I could just compare Doug and, well, let's do something a little different. There we go. So I have two strings. If I'm ever moving too quick, just hit the pause button. I like to make videos in which we use the pause button. All right, so the only difference between string 1 and string 2 is an uppercase A. So let's compare these to see how they work out. So copy that guy, paste that in there, and we're going to change this up a little bit. Let's say we want to go strings equal and see if those strings are equal or not. How we can do a comparison between these two guys is we can go string 1 and equals and throw string 2 inside of there. And that's one way to set that off. Also going to be able to compare another one. Let's go and do a different thing here. And this is going to be a comparison that is going to, instead of giving us true or false, it's actually going to give us a 0 in the situation which the string is equal. If it is negative, it's going to be a value that's less than 0. If it's a positive, it's going to be greater than 0. So what we can do here is, let's do a slight compare. Let's go compare A to B. And we can come in and like this. And we can just come in, throw the A inside of there like that, and we'll use compare to here instead of equals. So compare to, and we'll throw B inside of here just to see how that works out for us. And you can see we can put our double quotes inside of here without having to backslash them or anything, and everything works out perfectly fine. And let's run that just to see what all of that stuff is. And you can see right here, comparison A to B is -1. Right here, you can see even though the only difference is a capital A, that comes back as false. String length, and you can see how I added all that stuff together and all of that other stuff. So pretty neat stuff. Let's go in and do a couple more of these. Just get rid of that. Let's say I would like to get a character at a specific index. I could do that as well. So let's say I wanted to get the second index, and I want to do that for string 1. Just leave string 1 be right there, and let's just change this to get, and then we'll come in here and we'll change that to 2. That's going to get whatever value is assigned to the second index. And this is giving me a little squiggle saying that I don't have to do it this way. I could also come in here and do it this way, and you could do it either way you wanted to do it. It's completely up to you. I can also come in and get a substring by providing where I want to start and ending where I want to end up to. So let's go, here I'll show you an example. So we'll come in here and let's say I want to go and get index 2 through 7. How would I do that? Well, let's do this with string 1 once again. Let's go and get rid of all this. And I'm going to go sub sequence. And if I want to get from index 2 to 7, what I have to do is put 2 to 8. Okay, it goes up to index 8, but it doesn't include it with the results. And then let's, as a final little way of working with strings, let's say I want to check to see if a string contains another string. And of course I can do that. And I'll say I want to check to see if it has the value of random somewhere inside of it. So I can say something like contains random. And to check that, I can just go string 1 and contains. And then inside of this guy, I can put in whatever I want to search for. So there's random. All right, let's run it. And you can see over here on the right side, index 1 through 7 gets me random. So we go 0, 1, 2, see? And that's how it gets random. Contains random comes back as true. What is the second index is R. Why is that? Well, that's because this is 0 index, this is 1 index, and whoops, and that's the second index. Well, now it isn't, but now it is. All right, so good. All right, so there's a rough overview. Of course, there are other functions available with manipulating with strings inside of Kotlin, but those are the main guys. And now I want to talk about arrays. Okay, so arrays are going to be able to store multiple values of multiple different types. And how we can create one is go var, and we can go, let's call this my array is equal to. And how we create an array is you go array of, and let's say I want to go 1 and 1.23 and Doug. Okay, so you can see we can put multiple different data types inside of here. You're going to be able to access these guys just like you did anything else by going my array like this. And let's say you want to get whatever's in the second index. That's how you do that. You can also change the value in a very simple way. Let's say I want to change whatever is in the first index. Just do it like that and go equal to 3.14, whatever you want. You can find out easily how many elements are in your array. Let's come in and let's go something like array length. And to get whatever that is, you just go my array. And this time we're going to use size. And that'll give us the array size. And we can check if an element is inside of an array. So let's say we want to verify that Doug is in array, the array that we have. We can do that. Just go my array. And then we're going to go contains. And we're specifically looking for Doug. And that's going to come back true or false if that's in there. We're also going to be able to get a number of elements in an array and have it return as an array. So we're going to go var like this, and I'm going to say call this part array because it's part of that array. And I can go my array and follow that up with copy of range. And if I want to get the first two elements inside of the array that I'm pulling information from, I go 0 and 1. And of course you increment that if you want more of it. We can then get the first element out of our array easily by let's just change this to first, and we can then go string like that and then type in first, first. So that's going to give us our first element. And you could also type in last if you want to get the last element or whatever you'd like. You could also get the index of a value. So let's say I wanted to find out what is the first index for Doug, where that shows up. String 1 once again. And in here, I'm going to go index of, and I'm going to type in Doug. And there's Doug. And let's run that just to see what all this stuff does. Whoops, I messed that up whenever I tried to do that. Whoops, let's change it back. All right, now it looks okay. So let's save that and let's run it again. Oops, I typed in string 1 instead of my array. Let's go and fix that real quick. My array and my array. Run it. And there you can see. Doug comes back. Where is that coming from? That's coming from right here where we said we wanted whatever is in the second index. Array length, you can see, comes back as 3. You can see the very first value stored in the array is 1, and you can see Doug index starts at the second index inside of our array. All right, so a whole bunch of different things there. Another thing that's really cool, and I'm going to show you how to do all kinds of things with what are called collections, an array sort of being one of these collections. Let's say I'd like to create an array of squares. How hard would that be? Well, I could go var, let's call this square array is equal to, I can call array and 5, which is the total number of indexes I want inside of there. And then what I want to do is I want to go through 1 through 5 and have the values multiplied times each other. Sounds hard? Not really. I'm just going to type in x and x times x. So for each of the index values, what it's going to do is it's going to multiply whatever the index is times itself. You're going to see here in a second exactly what that looks like. Now let's just go and print that. Print line like this, and we'll go square array and 2. All right, so and we'll run that, and you see it comes back as 4. Why? Well, because that second index is multiplied times itself. So it's the second one, comes in here, 2 times 2 is equal to 4. So that just created an array full of squares. And you could throw anything in there you want. I just used 5, but of course you can do anything. And one thing I forgot to mention is, of course, there are type-specific arrays, which means if you want to have an array that can only have one data type, of course you can. So you just go like this, and array like that, and integer, and then if somebody tries to store something inside of this array that is not an integer, it's going to throw an error. So you go array of, and 1, 2, and 3, and of course that is going to work out the way that you would like it to. All right, so I'm going to do more with arrays as the tutorial continues, but now I want to take a pause here and take a look at ranges. All right, so ranges are really cool. What they're basically going to allow you to do is to define basically a starting and an ending value and do all sorts of nifty little calculations in between it. So let's say I want to create a range that goes from 1 to 10. How would I do it? I just do that, and then I go 1 dot dot 10. There it is, automatically generated it for me. Likewise, I could come in here and have it work with letters. So let's just call this alpha is equal to, and I'm going to go double quotes here, a dot dot, and then I'm going to throw a z inside of there. So there we go. We just created lists automatically generating those for us. You're also going to be able to use in to search a range. So let's come in and let's say that we want to search to find out if R is inside of alpha. We can do so. So we'll say something like R in alpha, and then we can come in here, get rid of all this stuff, and then we will go R in, whoops, make sure you have that there, in an alpha, and it will tell us if it's if the R is stored inside of that range or not. We're also going to be able to create ranges that would decrement downwards. So let's say we wanted to go from 10 to 1. We could do so. We could go 10 to 1, and then we could go 10 and down to, and then whatever we want the last thing to be. We could create an array up to a value. So we can just go val 2 to, let's say we want to go 20 is equal to, and then we can go 2 dot, and in this situation we would say range to 20. And what else can we do? We could step through an array. So let's say each value inside of, or a range, I mean, so we can step through a range. So let's say we wanted to step through adding 3 each time. Starting at the first value, we could do so. Let's go val, and let's call this range 3 is equal to, and then we can go 1 to 10. And let's say we want to step through adding 3 each time. We can go step and 3. Not 2, of course. And what else can we do? We can, of course, cycle through a range and print information out. We could do the same thing with arrays, as you're going to see later on, or you can go back and test this out. So I can go 4x in, and we can go range 3, or we could do this with any of the other ones. And we can go print line. And what I'm going to do here is, just so we can tell what this is, I'm going to go range 3, and then we can go x. And that's going to print out all those different values. And of course, the final thing is we would be able to reverse a range. Let's use the for loop again. So I'm going to go for x in, and we'll go 10 to 1 and reverse, and put that there like that. And then we'll just print the information out again. So we'll go print line and reverse and x, and that is going to allow us to do all that, and we will run it, and you're going to see, did it work? What did I have? A little bug, 23, Oh, this is reversed. Sorry about that. I remembered it wrong, and let's run it again, and you can see everything here. So what we were able to do here with, well, it says is R in alpha. Remember, we used the keyword in to check if the letter R is in this range, and indeed it comes back as true. You can see we came down here and we went and added 3 to each of these values and then printed them out on the screen using this little for loop here. And you can see 1 plus 3 is equal to 4, plus 3 is equal to 7, and so forth and so on. And then we also came here and used 10 to 1, and we reversed it, and that's the reason why we have 1 through 10. All right, so a whole bunch of cool things we can do with ranges. More is coming as the tutorial continues, and now I want to talk about conditionals. All right, so of course there's going to be a bunch of different conditional operators I'm going to show you here, and you're going to have greater than, you're going to have less than, you're going to have greater than or equal to, you're going to have less than or equal to, you're going to have equal to, and you're going to have not equal to. You're also going to have logical operators, and like I said, I'm going to show you all these. You're going to have and, you're going to have or, and you're going to have not. All right, so I'll show you a couple examples of how they work using if and else if and else. So let's say we go and create a value here. Remember, this is an immutable. It's not going to change. So we're going to go val age. In this situation, age will not change. So I'm going to say if age is less than 5, in that situation, what we're going to do is we're going to go print line, and we'll say something like go to preschool. Maybe a little bit early to send a infant to preschool, but it's going to work in our world. And then you're going to be able to go else if. There's no elif or any of that crazy stuff inside of Kotlin. We can say age is equal to 5. And in that situation, we're going to say that you can go to kindergarten. And there's kindergarten. And else if. And now we can stack these using logical operators. So we could go and say something like, let's put 2 parentheses in there. If age is greater than 5, and meaning that both sides of this conditional operator has to be true for this to come back with the value of true. And if age is less than or equal to 17, in that situation, I'm going to say that we're going to calculate the grade that the student's going to be working or going to, and we'll do that by taking age minus 5, and remember, no semicolons. And then I will come in and go print line, and I'll say go to, and change this to grade, and then use string interpolation to throw grade inside of there. And then finally, we can say else, which is going to be the default. And in that situation, we'll say everybody else can go to college. And there you are. That's how if and else if and conditional operators and logical operators work. Why don't we see how it would work if we're using what is called when, which works like switch in other languages. When is very cool. Here, I'll run it for you just so you can see what the results are. Ran it, go to grade 3. Okay, so you can see it fell into this quadrant right here, subtracted 5 from the age, and that's the reason why it says grade 3. Now let's take a look at the when loop or conditional operator, and we'll go when age. And I'm going to show you a bunch of different things we can do here. So we'll go when age, and then we'll say, let's say we wanted to match a list. I know you normally wouldn't do this, but I'm going to do it just to show you, because sometimes it will work. You can just go 0, 1, and 2, and 3, and 4. And then come out here, put the little arrow in there, and go print line, and say go to preschool. Well, let's keep that the same. You're also going to be able to match a specific value. So we just go 5, like that, of course. That's going to work for you. And there we'll say go to kindergarten. Kindergarten, and there that is. We can also match a range, and we use in with this. So we'll say 6.17 and put an arrow inside of there. And here, just put our curly brackets, and we can do all sorts of other things. We can say grade is equal to age minus 5. And then we can print out that. So we'll say go to grade, and we will throw in whatever the grade is. So there's grade. And then likewise, you can have a default value, and that is else also. So we'll put else, and then we'll print this out and say go to college. All right, so that's if, else if, and else, as well as how to use when to do pretty much exactly the same thing in numerous different things. This is really cool. I love when. And you can see it gets exactly the same results. All right, so there is a rundown of some conditional operators and conditional things we can do. And now I want to talk about looping. All right, so basically, of course, you know, looping is going to allow us to cycle through arrays and ranges or collections and all sorts of other different things, and basically anything that implements an iterator function. So I already talked about for loops a little bit. Let's do another one. So I'm going to go for x in, and here we're going to use a range. So I'm going to go 1 dot dot 10, and it's going to cycle through 1 through 10, as you're probably guessing. Let's print that out, and we'll say something like loop. I don't know why I'm a stickler for uppercase letters, and then I'll just go X. All right, so there is how we can come in and work with, or basically cycle through a range. Now I want to do something a little bit neater, and this is what I'm going to do is I'm going to use a while loop, and it's going to guess random numbers. But you may be asking, how do we calculate a random number? Well, the neat thing about Kotlin is basically if there is a library inside of Java, you're going to be able to use it inside of Kotlin. So we're going to go import java.util.random. So there's a library we use to import or to calculate random values with Java, and automatically we're going to be able to use it with Kotlin. So pretty cool. So I'm going to come down here now and generate a random value. How do you do that? You go val, and I'm going to call this rand is equal to random, and then go val, and I'm going to call this magic number is equal to rand, and next I'm going to work with integers. So I want to find a random value from 50 to 1, or from 1 to 50, I guess is a better way of saying that. Let's change this to magic number lowercase, and now let's use our while loop. Of course, with while loop, like in almost every other language, you're going to have a value you're going to increment or work with that you're going to have outside or defined before the while loop. So I'm going to say var guess is equal to 0 and just have it figure out whatever the data type for that is. And then I'm going to go and generate my while loop. So I'm going to go while magic num is not equal to the guess. In that situation, I'm going to come in and go guess, and there's a shortcut way of adding 1 to a value, and I'm going to keep incrementing the value of guess until it gets to the point where it finds what it wants. And then in that situation, I can then say magic number was, and we'll just throw guess inside of there. All right. Now let's run these guys, and you're going to see how that works out. And there it is. It looped through, printed 1 through 10, and magic number in this situation was 19. Let's run it again, and now it's 15. Run it again, now it's 34, and you can see that the random number generator is working, and also the while loop's working. Another thing, let's go and do another while loop so that I can talk about continue and break. Or let's do this as a for loop. So let's go for, and we'll say x in, and I'm going to go 1 to 20. And then what I'm going to do is I'm going to say if x modulus 2 is equal to 0, modulus is going to give us the remainder of a division. And what this is used for is to check if a value is even or odd. So if it comes back x modulus 2 is equal to 0, that means it's an even number. In that situation, what I want to do is continue back to the top of the loop and basically skip over all of the even values. So I'm going to go continue like that. Then, after we get out of that, continue basically just skips everything else that comes afterwards and jumps back up here. And this guy up here, this for loop, is going to increment for us. Otherwise, I want to come in and go print line, and I'm going to print out an odd value. So I'm going to put it like that, and I'm going to go x is going to be what I print out. And let's say that I want to jump out prematurely if the value is ever equal to 15. How I can do that is I can say if x is equal to 15. In that situation, I want to break out of it, and that is how that's going to work. And if I run that, you're going to see that that indeed works. So it only printed out the odd values, and whenever it got to 15, it jumped out of the loop, even though this was supposed to continue going, and it ended. And that's how continue and break work inside of Kotlin. Let's keep doing some more. Let's go and create ourselves an array here. And var, let's call this array3. And let's define this as an integer array is equal to array of and 3 and 6 and 9. And what we're going to do here is iterate for the indices of our array. How we can do that is go for and I in array3 and indices. And what it's going to do is return the indices for each of the individual parts of the array. And then we'll be able to go in here and go print line like that. And let's say I want to get multiples of 3, which is what I stored inside of there, like this, and array 3. and throw an I in there. So that's a way to get all that out of there. And then the final thing is I want to output not only the index, but also the value for each of the values inside of an array. I can go 4 and then put double parentheses inside of there. And I'm going to say index and value is what I want to work with. I'm going to say in array 3 with index, parentheses once again, since that is indeed a function. And then I'm going to print this out. And I'm going to go like that. And index. And I'm going to get to the index. And that's coming from this guy right there. You're going to see more examples of how we're going to be able to pull information this way. And I want the value also. All right, so save that. As long as I didn't have any bugs, that's going to print out real nice on the screen. And indeed, you can see here, I went and printed out those values inside of our array by referring to their index. And here I printed out the index as well as the values. All right, so there is a whole bunch of different things about looping, and now I want to talk about functions. Okay, so whenever you're defining a function, it's going to start out with the word fun, and then it's going to have whatever the function name is, a list of parameters, as well as their data type, as well as a return type. So I'm going to do an example. So let's say we create a function called add. And then inside of parentheses, I'm going to say that it is going to receive a parameter I want to refer to as number 1. I'm going to say that this is an integer. And then I'm going to have a number 2. Let's say that's also an integer. Then after that, I'm going to put a colon and say its return type is an integer. And there's a bunch of different things we can do here. And here, what I'm going to do is go equal to num1 plus num2. There's the whole entire function all in one place. And of course, we're going to be able to call for it to work. So let's go 5 plus 4 is equal to, and we can say add and pass in a 5 and a 4. All right, so there it is. That is how we can do that. And let's run it just to see what it looks like. And you can say 5 plus 4 is equal to 9. Okay. Now, one thing that is interesting is that you actually do not need a return type whenever you are working with single line functions. This is a single line function, what we have right here. So let's go, and I'll show you exactly what I mean by that. Let's just copy this and just change it to a subtract, just so I can show you an example. So I'll throw that inside of there, change this to subtract. It's once again going to receive a number and another number. And another thing, well, since I'm here, I might as well talk about it. You can also have default values. So let's say we wanted to have a default. We could do that just like this. And then let's have the defaults be equal to 1 in that situation. You're going to be able to get rid of this int here in that situation, and it's still going to work out perfectly fine. And let's go and get this guy and paste it in there just so you can see that I'm not lying to you. So I'm going to say 5 minus 4 is equal to. That would be an interesting tutorial where I basically just make up a whole bunch of things and people think it's true. But that is not going on right now. I just want to make sure you're clear on that. Okay, so 5 minus 4 is equal to 9. What? Subtract. Oh, I went and flipped that there. All right, so we'll change that right there. And 5 minus 4 is equal to 1. Okay, so there is how to set default values, and also point out the fact that if this is a single line function, you don't need a return value, but put it in there, you might as well. All right, another thing. You're also going to be able to use what are called named parameters. And what I mean by that is you're going to be able to refer to these even though they're out of order. So I'm going to come in. I'm just going to paste this inside of here like that. And here I'm going to say 4 minus 5 is equal to, and I'm going to call subtract. So subtract, and then we'll go in and name the parameters. So I'm going to say I want to put num2 inside of here first, give it a value of 5, and then I'm going to have num1, and of course I'm going to give it a value of 4. That is perfectly fine. You can do that as well. You may ask yourself, well, what do I put inside of here if I don't have a return value? Well, you're going to put unit, not void. So let's go and create a function that doesn't return anything. Let's just call it say hello, and it is going to receive a name, which is going to be a string data type, and it is going to return nothing. So we put a colon in there and just put in unit, and then we can go and put equal to, print line, and then inside of here go hello, and whatever the name was that was passed inside of there. And we can call this guy. Actually, we don't need that right there. We can just go say hello and pass in Paul. I don't know. There we go. So there's that. And what else can we do with functions? There's a whole bunch. We can create a function that is going to return 2 values. And there's a couple different ways of doing that. Let's go val, and well, let's create a function outside of here. We'll come down inside of here, and this is going to return 2 values. So we're going to go fun next 2, and this is going to receive a number, and then it is going to return the next 2 in line. So whoops, to do so, we're going to put a colon inside of here and go pair, and it's going to return an integer, and then it's going to return another integer. And to do that, we can go return and pair, and I'm going to go num, whoops, plus 1, and then num plus, 2. Okay, so that's what that function does for us. Let's go and call it up inside of here. And how you do that is you go val, and the 2 things you want, I'm going to have a variable called 2 and another one called 3 is equal to, and I'm going to call the next 2 function inside of here. Well, make sure you spell it right. Next 2, and we're going to pass 1 value inside of there, and then we can come in and print this out just so that we know that it indeed works. So I'm going to say 1, and then I'm going to go 2, and then I'm going to go 3. Okay, so we run that, and we're going to see what a whole bunch of these different guys do for us. So 4 minus 5, where is that guy from? Oh, that's from this guy right here. And then we have hello Paul, that comes out there. And then here we were able to get 2 values passed back from 1 function. So a whole bunch of neat things, but there are more, and more are coming. You're also going to be able to send a variable number of parameters. We're going to create a function outside of here again. So I'm going to go function, and I'm going to call this getSum. And if I'm going to receive a variable number of values, I'm going to type in var arg like that, and then give it whatever name I want. I'm going to call it nums in this situation. And then I'm going to say integer, and then I'm going to say that this is going to return an integer, and then I'm going to go var sum is equal to 0, and I'm going to cycle through all of these values as if they are an array, which they are array. So to do that, I can use a function called for each, and that's a way to cycle through arrays. So I'm going to go n, and I can do, for each of these values, I can go sum plus, equal to n, and that's going to cycle through every value in the array that's passed inside of there and add those to the value of sum, and then afterwards it is going to return whatever the final value of sum is. And we can come in here and call this guy to execute. Let's just do a print line here just to keep it simple, and I can go sum, and then let's go and call getSum. So I'm going to go get sum, and 1, 2, 3, 4, and a 5, and there it is, and there it is, and you can see the sum comes back as 15. We're also going to be able to come in and define function literals. So let's say we want to have multiply like this is equal to, and we'll have num1 inside of there, and that's going to be an integer, and num2, and that's also going to be an integer, and then this guy is going to return whatever num1 is times num2. So we just go in here, put that there, and num1 times num2, and there that guy is, and we'll be able to come in and print this. So let's just do 5 times 3, and then call the function itself, multiply, and 5 and 3, and that'll work. And we could also, something else cool is we could calculate a factorial with tail recursion. I'm just going to show you an example of this. I'm not going to get into recursion and how that works. You probably understand it. If you don't understand recursion, just leave a comment below and I'll give you an example. All right, so I just wanted to cover this just to cover it. So outside of here, actually, I'm going to, let's get rid of this guy right there because we already covered that, and get some, let's just get rid of it. All right. So what I'm going to do is I'm going to go fun, and I'm going to calculate a factorial using tail recursion. So factorial x colon, integer, and I'm guessing you guys have seen me cover recursion a million times, so I'm just not going to talk about it right now. Like I said, if you guys want me, leave a comment and I'll give you an example. So I'm going to go tail recursion fun fact. I'm going to call this factail. And it's going to y, which is going to be an integer, and z, which is going to be another integer, and it's going to return an integer. And this is just a function that calls itself until it ends. And anytime you have a situation in which you're doing that, you have to have an exit scenario. So we're going to have our exit scenario be whenever y is equal to 0. In that situation, we're going to return z. Otherwise, we are going to continue having our function call itself. So we'll say return, and we'll call factorial tail, and we'll go y minus 1 and y times 2, or y times z. And I guess I should talk about what exactly a factorial is. A factorial is just 5. Let's say you have factorial 5, you would go 5 times 4 times 3 times 2 times 1. Okay, that's a factorial, so that's what I'm doing here, just decrementing that. And then after this, after it finishes all this stuff, we will go and return factorial tail and x and 1. So we can save that, then we can jump up inside of here and show you what that looks like whenever we execute it. So we'll go print line, and we will do factorial 5 just because that's there. So that's the factorial symbol, and we will go fact, and inside of here throw in the value of 5. So we'll save it and run it, and you'll see that the factorial of 5 is equal to 120. All right, so neat stuff, and more stuff with functions is coming. Now I want to talk about higher order functions. Okay, so a higher order function is just going to be a function that either accepts or returns another function. So let's just go and create a whole bunch of examples here, make that all make sense. So what I want to do here is I want to use a filter, which is going to be a collection operator to find even values in a range. And I'm going to do a whole bunch of the different collection operators because they're really neat. So I'm going to go num list and define a range from 1 to 20. And I want to use filter on this to just find my evens. So what I want to do is go val and even list is equal to, and we'll go num list and follow that up with a filter, and I can put it inside of here. Basically how the way this works is if a function has only one parameter, you don't have to declare it, but you just use it instead and it'll just work. So here, this is going to represent each of these individual values in the range. I'm going to go it2 is equal to 0 and cycle that guy off, and then I can go even list and then for each, and then define that I want to print out all of those values. So we can go n and print them. So print line and n. So that's going to cycle through and print all of those different guys, all those even values. And we can run it and see that it worked. All right, so neat stuff. All right, so now I want to do something a little bit more complex. I want to call a function that is going to return dynamically a created function. So outside of here, I'm going to call this guy, basically what this is going to do is return a custom function that's going to multiply values times the value that's passed in. So I'm going to go function, and I'm going to call this make math function. It's going to receive a num, and it's going to be an integer, and then it is going to return a function that is going to multiply values times the num1. So what I do is I define that this guy, this function that is going to be returned, is going to receive an integer, and then what it's going to do is return an integer, and then I define exactly what I want it to do. So I'm going to go num2 is like this, and then we're going to go num1 times num2. All right, so it is a function that generates functions. Pretty cool. All right, so let's go and run it. So I'm going to go val, and let's say I want to create a function that multiplies values times 3. Well, I just call my make math function, and inside of this guy pass the value of 3. And that's going to get that inside of there, and it's going to create this custom function for me. So of course I have to make this be equals to, come down inside here, and then we can test it to show that it indeed works fine. So I'm going to go 5 times 3 is, times 3 is going to be equal to, and I can have this be multiply 3 times 5 and run it. and you're going to see the 15 comes back. All right, so that's a function that creates functions. Now we're going to create another one. And what this is going to do is it's going to receive a list and a function to use on the list. So I'm going to go fun. I'm going to call this math on list, num list, and it's going to receive an array, and more specifically an integer array, and it's also going to receive a function. So this is going to pass a function inside of a function, num, and this is going to be an integer, and we're defining what it does. And this function is going to return an integer. And then what I can do is go for num in num list. For each of those values passed inside of there, I am going to print out some information. And for this one, I am going to say math on list, just so we can see what's going on there. And then I can refer to any function that is passed inside of there as my func, and num on each of those items. Come back up inside of here and call it. So I'm going to go value multiply 2 is equal to, and I can go num1 integer, and then I can go num1 times 2. So there is our function. Let's call this num1. There we are. And then I'm going to go val num list 2 is equal to array of, and let's go and create an array 4 and 5. And then I'm going to pass in both the array as well as the function I want to operate on there. So math on list, and we can go num list 2, and then multiply 2, and we can run it. And up, what did I do? I didn't type in math on list. That's okay. Math on list, there we are, and run it. And it gave me another error, 15. What's that error? Da 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 da. Didn't make that uppercase. I fixed it now, didn't I? Yes, I did. Let's run it again. And you can see that it went and multiplied 2 times each of those values in the array. All right, so pretty cool stuff in regards to higher order functions. Now I want to show you some collection operators. All right, so these collection operators are going to work on any type of collection. So arrays, and you're going to see, I'm going to cover lists and maps, and there's a couple other different collections, but either way. So let's say we wanted to sum all the values in a list. We go val and list sum is going to be equal to number list 2, which is what I have right there. And I can call reduce to do just that. And what I need to do with reduce is go x and y and say that I want to sum those values together. And you can perform all sorts of other different operations. Fold is kind of like reduce, but it starts with an initial value. So I can come in and grab this guy like that, and I can do, well, let's also come in and print this out. So what did I do? Let's go print line and reduce sum, and then print out that list. So we're going to go list sum, and I'm going to do the same thing with this guy so you can see the difference between reduce as well as fold. So with fold, what you're going to do, change this to list sum 2, change this to fold, and fold is going to start off with an initial value of 5, and then it is going to continue adding all the other values in the list to it. So let's change that to that, and let's change this to fold sum. So fold sum, and you can run it, and you can see that it is indeed summing all of those values. And the difference between it is 210 and 215, so you see that reduce and fold are very, very similar to each other. We can come in and check if any values are able to meet a condition. So let's say we wanted to do something like evens, and we wanted to check if any of these values is even. Well, we can go num list 2 followed by any, and then have your condition to be inside of there. And we're going to be able to use it once again, and 2 is equal to 0, and you're going to be able to get your answer from that guy. Just do a couple more of these. You're likewise, well, there's another one that is all. So in that situation, the only difference is all of them are going to have to be evens to come back as true in that situation. You could also come in here and return a list of values that, again, meet a certain condition. So let's say we say val big3 is equal to num list2, and you use filter for that. And here I'm just going to define my condition. So greater than 3. And those are going to be the ones that end up going inside of that. And let's go and print those out. We can go big3 dot for each, and then let's go and print all of them out. Dot and print line, and here I'll just put greater than 3. You'll know what that means. And then print all those values out. Let's run it, see what it looks like. And there you can see all those values come out, and true and false show up right there. And for our final example, I want to show you map. And basically, map is going to allow you to perform an action on every single item and then return a new list. So here we're going to go val times 7. So I'm going to multiply everything times 7. And we're going to do that on our number list too. Call map, and then define exactly what I want to occur in that situation. So I'm going to take each of those items and multiply them times 2 and save them to a brand new list. And then we can say times 7 dot for each, and then print them all out. So cool stuff. So print line, and then we can go like this, and times 7, and print those all out. I think I got that all right. Yes, I did. And we can run it. And when we do, you're going to see every item printed out, or multiplied times 7 prints out. So there you go. There's a whole bunch of different collection operators that are available to you. And now I want to talk about exception handling. And you all know what exception handling is used for. It's handled, or it allows us to handle errors so that the programs do not crash. So I'm going to use the same type of example I always use. I'm going to have a division by 0. So I'm going to have my divisor be equal to 2 in this situation. And I'm going to do a division, which means there's a potential for a division by 0 to occur. Inside of here, I'm going to say if and divisor is equal to 0. In that situation, I want to throw an exception. So I'm going to say throw illegal argument exception. That is it. And in this situation, I'm going to say can't divide by 0. Else, if there was no problem with that, what are we doing here? There's a little problem here. Get rid of that. And throw that up there. All right, now everything's okay. Else, if that wasn't a good one, we can come in and we can say, get rid of that, and we can say something like 5 divided by, and let's put our divisor inside of there, is equal to, and we will do our division inside here. So 5 divided by divisor. Okay, so everything's fine. Now anytime we have a try block, we are going to try to catch our error. And in this situation, we're going to go E, and we're going to follow that up with illegal argument exception. Of course, we're going to catch the exact exception that we sent, and then we are going to, or if you'd like to, come in here and print out the message that is tied to that exception. You can go E dot message, exactly like that, and it will print that out. And we can run it, and since divisor is 2, we have no problem. But if we come up here and change the divisor to 0, and you're going to say that it just goes and prints can't divide by 0. All right, so very, very, very brief explanation of how exception handling works inside of Kotlin, but I think you can catch on with the rest of it. Now I want to talk about some collections, and I'm going to start off with lists. Now, basically, there are immutable lists and there are mutable, what are referred to as mutable lists. All right, so what I want to do here at first is I want to create a mutable list, and then I'm going to create an immutable list. So we'll go var, and I'll call this list1, and this is a mutable or a changeable list. Mutate, change, get it? All right, so we're going to go int, and then I can go to populate it. I call mutable list of, and 1, 2, 3, 4, and 5, and there you go. I just created a mutable list. If instead you would like to create an immutable or a list that does not change, we're going to come in here and change this to val instead of var, and we're going to change this to list2, and then this is going to just be changed to a list, so it's an integer list, and then we just come in here and change this to a list of, and let's just copy or cut off that little part. Okay, so here is a mutable or changeable list, here is an immutable or unchangeable list, and that's how we create those. Now I'm mainly going to be working with the mutable lists here. Let's say I want to add an item to a mutable list. I can go list1 and add, and we can throw anything inside of there. That's how we add values. Let's say I want to get our first item. Well, don't want to do that. Let's go print line, and I want to get our first item out of it. I can do so, and let's get this, and list1 followed by first. There that is. That's how to get that. That's the first item in the list. Let's say I want to get the last item in the list. Well, guess what? We type in last, and we just type in last like that. And we can do a whole bunch of other things. Let's say we want to get a value at a specific index. Let's say we want it to be the second index, seconds, and to do that we can just go list1 once again, and let's just say change that to 2. That's how that operates. We can get a list starting from one index to another. So we're going to create list3 is equal to list1, and we call sub list, and go from 0 to 3, and that's going to create that. That's how to get a sub list. We're also going to be able to get the size of our list. I'm going to call this length, and we can call this list1 and follow that up with size. And of course, we're going to be able to clear our list. So let's go list3 followed by clear. That's going to get rid of everything inside of the list. We can remove a value. So we'll go list1 followed by remove. And let's say we want to get rid of 1. We could also remove at a specific index by saying remove at, and changing that to 1, and we could add a value at an index. So let's go list1, and let's say we want it to be in the position of 2, and what we want to add is 10, and of course we can come in and cycle through all of these items inside of here by calling for each. And then after that, let's get rid of this right here. After that, we can go n and what we want done to each of those items. And here I'm going to say print line, and I'll go mutable list and print out each of those items. And everything looks okay, I think so. Whoops, I went and hit enter right whenever I did that. All right, let's undo that. Save it and run it. Whoops, what did we do? There is an error warning 13. What's going on with 13? Oh, list 2 is never used, but that's not our main error. Let's get rid of that though, just for the heck of it. Look over here, and what do we have? We have an error on line 32. Always ignore this and this. This is your specific application. Your error is in 32. Let's look at 32. Oh, I see what I did. There's actually no index 2 in this situation. Let's just get rid of that altogether, and we can save it, and we can run it. And you can see right there, it is going in here, grab the first value, grab the last, or output of the last value. The second value was 3, the length was 6. Then we went and removed a whole bunch of different things, and you can see that it printed out 4 and 6 for all of those different items in our list. Okay, so there's a whole bunch of functions and ways to work with lists, and now I want to talk about maps. Okay, so a map is going to be a modifiable collection that's going to hold key-valued pairs. And let's go and create an empty map. So I'm going to go map is equal to, and of course there's going to be mutable maps and immutable maps. What I'm going to work with here is a mutable map, and how you load one is you go mutable map of, and here I'm going to define that the key is going to be an integer, and the value in this situation is going to be anything. And we go like this, and there we go. So now we created our map. Now it's time for us to use our map. let's go. Well, I'm also going to show you how to create a map in which you load values whenever you first start it. So let's just call this map2 is equal to mutable map and mutable map of, more specifically. And then in this guy, what I'm going to do is I'm going to say, get rid of this and have it figure it out. And I'm going to say 1 to Doug. And then I'm going to put another element, which is going to be 2 to 25. Okay, so this is going to be the key, and this is going to be the value that we are going to be working with. I can also add additional values. Let's go map 1, and this is going to be to the guy that doesn't have anything. So I'm going to throw Derek inside of there, and I'm going to go map and 2. Again, this is the key and the value. We'll throw 42 inside of there. I'm going to be able to get the size of these elements by just going, let's call this map size, and then I will just type in map size and map and size, and there that is. We can also add a key value, so we can go map and put and say 3, and let's say we want to put in Pittsburgh. There that is. We can also come in and remove a key and value, so we go map and we will use remove. And I'm going to remove whatever is in the second key or whatever is assigned to it. And of course, we're going to be able to iterate and get key values. So I'll say 4, and I'm going to say X and Y and in map. And the X is going to be the key, the Y is going to be the value. And we can go print line. And just to show that, I can say key, and there's X and value. And let's make that uppercase, value and Y. All right, and run it. And you're going to see that map size 2 comes out with this guy right here. And here it cycled through the different values and printed them out, the keys and the values. Okay, so brief explanation of how maps work in Kotlin. Now I want to talk about classes. All right, so we're going to create a class outside of the main function right here. And I can get rid of this random function or this random import up here because I'm not going to use it anymore. So we can come down here like this. And it's important to understand up front that there are no static methods and that classes are going to be marked as final, like in Java, by default, unless they are marked as open. So I'm going to mark it as open. Whoops, if I could spell open. There we go. So open, and I'm going to create an animal class, and you're going to put the attributes you want this guy to be set up with directly thereafter. You're going to put the data type. You're also, let's say I want to have every animal is going to have a name and a height. Now let's put that there. And maybe it makes more sense to put these on multiple different lines. And also, you can see I'm using val here because this is not going to change, and var here because the height as well as the weight could change. So let's put that inside of there. And there is double. Okay, now let's continue adding on to all the different things. I wish this wasn't quite so verbose with all the squigglies everywhere. It drives me nuts. But either way, basically your objects are going to be initialized in an init function. And this is just going to be where you are going to verify if a value is okay or not. So let's also talk about regular expressions here very briefly, like 3 lines of regular expressions. Basically what I want to do is I want to create a regex here that is going to match for a number any place inside of a string. So let's say I want to make it invalid to have a number inside of an animal's name. Well, how I can define this regular expression is like this. And regex, and put this like this. And then what this is saying is basically I'm checking to see if there is a decimal value anywhere inside of a string that's going to be assigned to name. And what I'm going to do is put require inside here. And basically what's going to happen is if these requirements aren't going to be met, an illegal argument exception is going to be thrown. So I talked about exception handling a little bit ago. So what I'm going to do here is I'm going to say if name matches any character inside of name matches for the regular expression that we have up here, which means any of the characters are numbers. In that situation, what I want to do is I want to throw an error. So I'm going to say animal name can't contain numbers. All right, so that's going to be the message that I'm going to shoot out. Let's go and do them for other ones too. So we'll say something like require, and here I'm going to say if height is greater than 0, what I'm doing is saying that height must be greater than 0, and if it is not, the message I'm going to say is height must be greater than 0. Okay, and let's do the same thing. Another requirement of my class is that the weight of my animals must also be greater than 0. Otherwise, I will not accept them as valid animals. And then inside of here, outside of init, of course, I'm also going to throw in a method. And if you want your methods to be or provide for the option that your methods could be overridden, you need to put open here once again. I'm going to say fun, and this is going to be called get info, and it's going to output some information, but it's not going to return any information. And what is specifically it is going to output, let's get this out of here, is... Nope, didn't have that there. So we're going to say print line, and I'm going to get to the name. How you get the name value is you just go $name is, and here I'll just say height and tall and weighs. I'm not going to get into specifics of what type of values we're using, and there you go. So that's how you define the attributes. This is how you define what is valid values for all of the different attributes, and this is how you define a method for your class. Now what I want to do is come up here after I have that set up. I'm going to come up inside of main and go and create an animal object. How you create one is you go Bowser like this is equal to, and you do not type new inside here. You just type in whatever it's called, and then you want to say Bowser, whatever the name is, and let's say I want a 20.0 and 13.5 is valid, and then I can call for our function to execute by going get info exactly like that, and then we can run it, and as long as I don't have any errors, yes, Bowser is 20.0 tall and weighs 13.5. Brief explanation of how those all operate, and now I'm going to talk about inheritance. Okay, so what we're going to do is I'm going to create a new class. I'm going to call it dog, and it is going to inherit. Since I don't have open on here, you're not going to be able to inherit from dog, I've decided. So it's also going to receive a name, which is going to be a string, and it's also going to have a height, which is going to be a double, and it's going to have a weight, which is also going to be a double, and it's also going to have, this time I have to put a var, it's going to have an owner, whoops, owner, like that, and that's going to be a string. Now to say that I want to inherit from animal, I just put a colon in animal, and then I let the name, the height, and the weight be initialized over inside of animal. And then it comes down like this, and let's say that I would like to override get information. I just go override fun get info, and of course I can put my own methods inside of here, do whatever I want. This is not going to return anything, and let's just go and copy what this says. So let's just copy that, change it up slightly. So name is height, tall, blah 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 blah, and is owned by and owner. Okay, so there we go. We just created a dog which inherits from animal, and let's come up here and test it to make sure that it operates the way that we feel that it should. So I'm going to go val spot is equal to, and here I'm going to call dog and spot, and polymorphism is going to work in Kotlin just like you would expect it to. So let's go like this. So I'm going to leave that for homework for you to test out. 14.5, and Paul Smith is the owner, and then I'm going to go spot, and get info is going to print that out, and we're going to run it, and it should have worked. Yes, spot is 20 inches tall, weighs 14.5, and is owned by Paul Smith. Okay, so that's how inheritance works inside of Kotlin. Now why don't I give a brief explanation of how interfaces work. All right, so come back down here inside of here, and what I'm going to do is I am going to create an interface. So this is going to be an interface that is going to provide for the option to make something flyable. And an interface, of course, is just a contract that states that all fields and methods a class must implement if it implements the interface. So I'm going to call this interface flyable, and I'm going to say that anybody that basically wants to use the interface is going to have a field inside of it called flies, and it is going to be a boolean, and it also is going to have a fly method inside of it that is going to receive a distance miles flown or whatever, and it's going to receive a double, and it is going to not do anything, not return anything. All right, and let's leave that exactly the way we have right there. After this, you know what? I'm going to create a bird class that's going to implement that. So I'm going to go bird, and you're going to be able to call your constructor directly from inside of here and do something like val and name, and this is going to be a string, and I'm going to say right here, v override var flies, and to implement the interface here, what we're going to do is follow the constructor parameters with a colon and the interface name. Let's also come in here and make sure boolean, and let's give it a default value of true, and then I'm going to come in and go flyable. Flyable. It's getting late into this tutorial, messing up a little bit. Okay, so there's flyable, and let's go and put this down here so we can see more of this stuff all at one time. So there you can see it. All right, so there's flyable, and inside of it, we of course need to override the function fly. So there's fly, and this is going to be distance miles and a double, and of course it's not going to return anything. And let's put this down here because that's confusing me. Put that there, and then what I'm going to do is I'm going to say if flies in that situation, I want to print out that whatever the name of our bird is going to fly a certain number of distance miles, and then I'll say miles after that, and there that is. And did I do this right? I think I did. There's flyable, there's that, there's this, everything looks good. And then let's come up inside of here and test out our interface. So there's all this stuff. There we are. We're in the main function, and I'm going to create a bird. Let's call it Tweety. So is equal to bird, and the name is Tweety, and it is going to be true that Tweety is a flying bird. And then we can say tweet and call for the fly function to work, and we'll say that Tweety flew 10 miles. Let's run that and see if I have any errors. Oops, have an error. What do we got? Unresolved reference tweet, distance miles. Okay, so 17. Oh, Tweety. I misspelled that. Let's run it again just to see. Anyway, another error. 62, unresolved reference, distance miles. Distance miles, dist miles. Oh, dist miles. Let's change this to distance miles right there. Distance miles right there. Everything else should be okay. I'm just going to run it. And you can see Tweety flies 10 miles. Okay? So there you go. There's interfaces and a whole bunch of other different things. And to finish off everything, I'm going to talk about null safety. Okay, so null safety is built directly into Kotlin because null causes lots of issues. So Kotlin, that's one thing that Kotlin tries to do is to solve potential issues. Now, by default, you actually cannot assign null. And I'm going to show you this. I'm going to go null value like this, and string is equal to null. Okay? You're going to see that it gives me an error. What it says is null cannot be a value of a non-null type string. Okay? So you can't do that. However, you can allow for a null value to be assigned. And how you do that is you just put a question mark inside there. And there you can see that the error went away. Now, another thing is a function may return null. And in the situation in which that occurs, you're also going to use our little question mark. So let's go fun and my fun for function and string. So if there's a chance that this could return a null value, you are going to put the little question mark there. Let's go and actually do a real world example here instead of just doing something a little bit weird. So we're going to go fun, and this guy is actually going to return null all the time. So we're going to go return null, and we will put string inside of here like this and create a function. And the whole purpose of this function is to return null, to cause, issues and so forth. You can see right there, I did it and it did not give me any errors. Another thing that is neat is that Kotlin is going to provide for the opportunity of a null value if an if statement is going to protect it from danger. So what we're going to do here is I'm going to go var and null val2 is equal to return null. So we're going to call that function that's sole purpose is to return the null value. And then what I'm going to do down here is I'm going to use what Kotlin refers to as a smart cast. So I'm going to say if null val2 is not equal to null, in that situation, I am going to go in here and try to print it out, or print out length of that. So I'm going to say null val2 dot length. And there that is. Now, if I didn't have this here, this would be throwing an error. But since I do have that if statement there, like I said, it's called a smart cast, and Kotlin's smart enough to allow me to do that since I caught the null issue myself. You could also use the force operator to force a null assignment. So in this way, we go null val3 is equal to null val2, and then you put 2, that's the force operator, 2 exclamation marks, and length like that, and it's going to provide for the option. And then the final thing is you can use the Elvis operator to assign a default value if the value could be null. So, and how that would work is you would go var and null val4, and this is a string, and in this situation we're going to call the old return null, which only exists to return nulls, and there is the Elvis operator. It's going to be the question mark followed by a colon, and there we will say if you try to assign a value of null to null val4, instead install or assign the value of no name. Okay, so there you go, guys. Did my best to cover the vast majority of what you're going to need to get going in regards to working with a absolutely super awesome language, Kotlin. And if you guys have any questions or comments, please leave them down below. Otherwise, till next time.